Hey everybody, going old school. Gonna make videos back in the room because at least now the volume works and you can hear my voice. Do you understand the words that are coming out of my mouth? I hope so. Recognizing acids and bases. We're basically going to talk about how to name them and their properties, and you're not even really going to have to name them much, so that's not to worry. Okay. So, moving forward, come on. Properties of acids and bases. These are a mixture of chemical and physical properties. So they always produce H plus ions in solution. They react with water to make those H3O plus ions in solution. So remember, H plus and H3O plus are the same thing. H plus along with water, which is H2O, makes H3O plus. So if H3O plus is present, H plus is present, acid. Okay. They are tart tasting or sour tasting. So many of the foods that we eat have this in them. So number one, vinegar. Number two, probably acetic acid. So lemons or limes. Okay. They definitely sting in eyes or in your cuts like lemon juice. Okay. They definitely sting more than a base would sting. They also react vigorously with metals to produce hydrogen gas. This is something they do that bases don't. So keep in mind that this is one that where we can use to separate them. H plus and react vigorously, okay, and sour and tart. They are electrolytes and so are bases, so don't get that confused. I cannot differentiate an acid from a base just on the fact that it lights the light bulb. Both of them will do that. The other one I can differentiate is acids turn litmus paper red. Litmus paper is, first of all, litmus is one of the pH indicators. And using litmus paper is probably something you did in earth science at least once or twice. They make different kinds of litmus paper. They make one that's just a solid color and either turns red with acid or blue, we'll find with base. And then they make some that have multiple colors in them. So whatever color it turns, you can hold it up to the little range and see it'll actually narrow in the number of the pH. That's the stuff I have. I actually have both laying around, and I'm not sure what we'll use, if we'll use any at all, but we will play with indicators. They do look like pure water, and honestly, acids look this way more than bases. You really can't tell that an acid is an acid just by looking at it because it looks perfectly clear like water. I'll explain to you the difference with a base when we get there, which is where we are now. So conversely, bases make the OH minus in solution, and then again, either directly or indirectly. So the directly follows Arrhenius. The indirectly for NH3 is that Bronsted-Lowry or the alternate base theory. But either way, when introduced with water, OH minus becomes very prominent, hence it's a base. They are bitter. Dark chocolate is basic, and it's got that little bit of a bitter bite to it. Okay, so they are bitter. They react with skin oils to produce that slippery feel. They're literally reacting with the lipids in your skin, the fat, and producing soap right on the surface of your skin. Okay, and soaps are basic. It's part of how we clean oil and grease so well. They, again, are electrolytes. So bases are electrolytes. And they turn litmus paper blue. Okay? So that's different. Bases turn litmus blue. And then they look like pure water, clear and colorless, but they do have this one funny thing. If you make a strong enough base, I'm sure that you've seen, like on the road in the summertime, in the distance, in the heat, you see that ripple kind of coming off. And it looks a little weird and kind of wavy, and you're not really sure what's going on out there. This will happen actually inside the liquid. It'll have that very much same look if the base is strong enough. So you can't really, it's still very clear, it's still very transparent, but there is sometimes that weird, funny thing, just like what's happening on the road with all the heat. So you will sometimes be able to see a base where you can't see the acid. Okay, and these do not react with metal, so you cannot differentiate based on will it react with a metal. That's not how I can tell an acid from a base, okay? I'm sorry, it is how I can tell an acid from a base. Sorry, it's early. So they don't react. Bases don't react, acids do. Salts. Just to clarify, all ionic solids are called salts generically by chemists. We're not always just referring to table salt, and I know I've said that about 1,000 times. They are the product of a neutralization reaction with an acid and a base. We have a whole video on that. But that's why it's important, is because they're going to show up in a little bit with some of the stuff that we do. What makes them different than an acid or base is when they dissociate, they don't produce H plus ions. Okay? And when they dissociate, they do not produce OH minus ions. If the salt did that, that salt would be an acid or a base. Okay? So that's what differentiates a salt from an acid and a base. A salt is an ionic compound that dissociates not producing H plus or OH minus. Naming these things, you really are not responsible to just, here's the formula, name it, okay? You're responsible for, here's the formula, look it up in table K and tell me its name. Let's be honest, this is not like naming ionics and covalents. This is not like naming organics in unit 10. Okay, so there is this way to tell, though, that they all end in ic acid for the most part. There's a few us's. There's two us's, and notice they differentiate. They have a different number of O's. So one's nitrite instead of nitrate. There's, honors chemistry ways to remember that stuff, and you really just don't need to. It's you just need to be able to look it up. Okay, and then this whole root followed by the ic acid. Here's one that kind of defies that, I'm not going to lie, because there's the hydro, and it's the only one with the hydro. So I just want to put that out there, that chlorine is going to become chloric acid. And it could have just been called chloric acid, just like I have nitric acid, and I have sulfuric acid, and I have phosphoric acid. So this could have just been called chloric acid. I'm really not sure why it's called hydrochloric acid, but it's the only one that defies the normal naming structures. And notice you only really need to look up the name. The nice thing about the acids and the bases for Regents chemistry is I'm not going to deviate from the acids that are on that list, and I'm not going to deviate from the bases on this list. So that's nice. The most bases have the name of the metal followed by hydroxide because of the OH. So you take Na, you got sodium, and you got OH becomes hydroxide. Put it together, it's sodium hydroxide. Pretty easy. You look that right up. The only one that's different is ammonia, which is NH3. And again, we're looking those things up anyways, so we're all good. And we're donezo.